Hey people, welcome back. And in today's session, we are going to learn about individual distribution identification. So the purpose of individual distribution identification is to identify the appropriate distribution or the best fit transformation for your data before you perform any statistical analysis or any hypothesis testing. This involves verifying the distribution of the data, determining whether the transformation will adequately normalize the data or not, and comparing the different distribution to choose the best fit out of that. Which data distribution fits best for your not normal data? So when you are an engineer and you perform an individual distribution identification to determine which distribution best fits the data, and this tool can be used to evaluate the optimal distribution for data based on the probability plot, like as goodness of fit test before you conduct any capability analysis. Suppose your data is not normal and you have to conduct a not normal capability analysis. So which is the best fit distribution for your data you should be choosing upon? How do we do this? Let's understand in the Minitab. Suppose here we go in Minitab and I generate any non-normal data. So let's say I choose from any, there are so many kind of distribution, and I choose, suppose I'm choosing the exponential distribution, let's say here. And selecting the exponential distribution, maybe 50 values I am generating on column C1, which is not normal. And with the scale of 0.5, or maybe you can say, let's say 1.5 with the threshold of 0.01. Click on OK. And these 50 values are generated here, right? Now, if I want to find out what data distribution, so first thing we check the normality of the data. We'll go to the stat, basic statistics, and here is the normality test. I selected this data, Anderson-Darling test, and click OK. And I look, my p-value is less than 0.05. If the p-value of the data is less than 0.05, which means this data is not normally distributed. So what? Before I perform any analysis, I should be knowing what distribution my data fits well. So to do that, we identify the distribution. So for that, we'll go into Stat, Quality Tools, and here is the option Individual Distribution Identification. Click on that. Select your data, subgroup size by default 1, and you leave all the distribution like is, all the use distribution, all the distribution and transformation, and click on OK. And now, once you do this, you will see so many of the best fit table will come or data distribution tables will come. You need not to worry about any. You directly jump into goodness of fit test. And when you look at the goodness of fit test here, whichever the p-value is the highest, that distribution your data is following. So if we look here, my data is suggesting for the transformation, which I'll explain in the next session. If you do with the box Cox, data will be transformed with the p-value of 0.672. And if you use the Johnson transformation, data will be transformed with the p-value of 0.492. But suppose I need to do the process capability analysis where I really need not to transform the data. So I will look which p-value is the highest. And out of this data, I look if I leave the transformation because I really need not to transform the data as of now, suppose. So the highest p-value in this data is coming as an 0.369, which is for the exponential distribution. So this particular data, what I have generated, this data fits with the exponential distribution. So in case in statistics, I want to go for any further analysis, I should be considering my base that my data is distributed exponentially, and all the analysis I should be conducting as per the exponential distribution. And that's what the importance of individual distribution identification. This will help you that which particular shape is my data is following as in distribution, and I can select my statistical analysis according to that. Thank you so much, people. I'll see you in the next session.